Okay, what is a conservative force? A force is a conservative force if the net work it does on a particle moving around any closed path from an initial point and then back to that point is zero. So, for example, if there is a conservative force, let me continue. Equivalently, a force is conservative if the net work it does on a particle moving between 2 points does not depend on the path taken by the particle. What are the conservative forces? Gravitational force is a conservative force. Electrical force is a conservative force. The spring force, expressed by Hooke's law, is a conservative force. These are conservative forces. The kinetic friction force is non-conservative force. So based on these definitions we are given here, for example, we can say if an object goes from here and goes back to where it was, we can say the work of mg is equal to 0 in this closed path. So the work it does, the work of gravity in any closed path, or when it comes to the initial point, is 0. Or, for example, if there is an electric field here, we want to go from point A to point B, we want to move a charge, we want to move a positive charge, for example, from point A to point B. It doesn't matter how you go from point A to point B. The work of electrical force will be the same. It does not depend on the path taken. So in whatever way you go from A to B, the work done by electrical force will be the same. Okay, so the work done by electrical force, the work done by gravity, the work done by spring force are like this. They are path independent, and in a closed path, when we have initial point and the final point will be the same as initial point, the work of these forces will be 0. And because they are path independent, for example, it only depends on the point, we can define a function for these forces. So conservative forces are associated with potential energy. So that function will be potential energy function. So conservative forces will be related to some potential energy function. For example, for gravitational force, we will have gravitational potential energy. For electrical force, we will have electrical potential energy. And for spring force, we'll have a spring potential energy. Okay. Let's do one example. A 5 kilogram block slides down a frictionless inclined plane. If the initial height is 3 meters, calculate the work done by gravity once along the inclined plane and once in vertical and horizontal direction. So assume that the initial position of this mass is here and the initial height is 3 meters. Let's name this point as A and this point to be B and this point to be C. So I want to calculate the WMG once in the path AB, and once I want to calculate the work of gravity in the path ACB. So once in the inclined plane, along the inclined plane, and once vertical and then horizontal direction. Okay, we can apply the work formula here. The angle is given to be 30, and therefore this angle will be 60. So the gravitational force has an angle of 60 with the direction of displacement here. This angle is the same as this angle, which is 60. So mg times d times cosine of 60. D cosine of 60 will be the same as h, or 3. Therefore, 5 times 10 times 3 will be 150 joule. The work is positive because the angle between force and displacement is an acute angle. Now, in the path AC, the direction of displacement and force is 0. They have the same direction, the angle is 0. So it will be mg times height times cosine of 0, which will be 1, plus, and then in the horizontal path CB, the direction is leftward, and the direction of displacement is to the left. Direction of gravitational force is perpendicular downward, and therefore the angle is 90. So mg times CB times cosine of 90. So in this horizontal path, the work by gravity will be 0. So the same number will be found. The same number of 150 joule will be found. So we conclude that the work of gravity, as we said in the previous slide, the work of gravity is independent of the path. It doesn't matter where we go from A to B, from in this direction, or in this direction, or in this direction, or any other direction. The work of weight, or the work of gravity, between point A and point B will be 150 joule. It is path independent.